Now what we're going to do today is try and simplify before we multiply. Whenever you have ones as numerators, chances are you're not going to be able to simplify at all, anytime, okay? So there's nothing I can do there. Now look at this one. So 3 and 2, do they share any factors?
6.
No. 2 and 5, do they share any factors? No. I don't mean multiply them. I mean, what can I multiply together that makes 3? 1 and 3, right? What can I multiply together that makes 2? 1 and 2. So the only factor they share is 1. That's not going to change anything. So you just multiply in that case. So 4/15. Now look at this one, and I'm going to start pulling sticks here in a minute. Okay? Whenever you have numbers that are exactly the same, you can divide by itself, right? So 3 divided by 3? 1. Okay? Then I'm going to go ahead and cross off 4 and 2 because 2 times 2 equals 4, correct? So I'm going to divide by 2. 2 divided by 2?
1.
4 divided by 2?
2.
So your answer here is 1/2. Okay? What about 1 and 4?
No.
What about 2 and 3?
No.
So let's just multiply. Okay, I'm going to start pulling sticks now. For me, what could I cross off here? The 3's. 3 divided by 3 is 1. That's sort of like they cancel each other out, don't they? So what am I left with? 2/5. Okay, let's keep going. George A., what can I cross off here?
4 and
4 and 4. So my answer? 3/5. Okay. The next one, Jesus. What could I cross off here? The 3 and the 6. So we're going to divide by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. Now I have to multiply. 5 times 1 is 5. 2 times 4 is 8. Okay? All right, let's look at the next one. Abdiel, what do you see in the next one?
5 and 5 is 6
You're-
and 3.
You're right. So we just did 6 and 3, didn't we? Turned out to be a 1 and a 2. So what's your answer here? 1/2. Okay? Now, is that easier than the first time I showed you? Or is it still pretty confusing?
Easier.
It's a little easier maybe? Okay, so we're going to practice that a little more. Let's take a look at the next one. So on this page, there's a couple reasons why I want you to write it out. Can you remember what one of those reasons is that I want you to write it out? Time to think. Do I need to pull a stick here? Well, we have to multiply 3 numbers, right? So my original thought was, if I have the kids write it out, they won't forget to multiply the third number. Okay? So the length is
4.
the width is
2.
and the height is
3.
3. Okay? So how would you group the numbers, Beverly? There's no right or wrong answer. What would you do?
I would do 2 times 6.
2 times 3. Okay, so here's how you write it. 4 units by 6 square units. And then 4 times 6 is
24 units.
cubed, because this is volume, cubic units, okay? There's another reason why I want you to, and it's right here by this star. There's another reason why I want you to write it out. I want you to remember that if I know the area of one face of the cube, and I know the height, I can figure out the volume. And here's what the formula looks like. Now, volume usually is length times width times height, right?
Yep.
But you could also do volume equals base times height. And sometimes you see it written like that. This is another way you see it written. volume equals BH, and that means base times height, okay? And whenever you have this formula you need to use, or this one, your word problem is going to have square units in it. But you have to figure out volume, okay? So that's another reason why I want us to get used to writing it out, so you will recognize that I can take square units times one more length and get my volume, okay? Because coming up on math test, I feel like you're going to have some volume questions, and I'm trying to prepare you for that. Sound good? That's not showing up very well on my paper. All right, so I'm going to pull sticks on the next one. This is Josue. Josue, what's my length?
5,
5. And my width?
3,
And my height?
2.
Okay, how would you group them, Josue? You can choose. It doesn't matter.
The 3 and 2.
The 3 and 2. Okay, so you would write 5 units by 6 units squared, and that equals 30 cubic units. Okay? Miliano, help me with the next one.
6,
And
2,
and
4.
good. How would you group these?
2 and 4.
2 and 4. And you can group them however you want. If you want to do 12 times 4 and you have that memorized, go right ahead. So this is 6 units by 8 units squared. And that equals 48 cubic units. So there's a little review of volume, okay? All right, this is a word problem. Now, look at the board because that's how many people are stuck on Zern Lesson 12. Yikes. I know. What we're doing today at 1:30, guess what we're doing today at 1:30? Zern. Okay? And as soon as you're done with the blast on 13, you can get on Some Dog if you want. Okay? So when we solve this word problem right here, that's going to remind you what you are going to need to do to finish lesson 12. All right? The Colliers want to put new flooring in a 6.5 foot by 7 1/3 foot bathroom. That's a tiny bathroom. Can you get the door? The tiles they want come in 12-inch squares. What is the area of the bathroom floor? If the tiles cost $3.25 per square foot, how much will they spend on the flooring? What are the 2 questions that are asked here? There are 2 of them. Emily, give me one.
What is the area of the bathroom floor?
Good. What is the area of the bathroom floor? And I'm going to go ahead and highlight that.
Can we circle it?
You can. Or underline it. And the next one, Chloe, what's the second question that's being asked?
How much will they spend on the flooring?
Good. How much will they spend on the flooring? So we've got a 2-part problem. On this 2-part problem, I'm going to give you, draw a line about here. Because the second part is not going to take up much room. The first part's going to take up the most room. Okay? So the first thing we'll figure out is the area of the bathroom. What is my problem, my multiplication problem, Jair?
Huh?
What's my...
6 and 1/2 times 7 and 1/3.
And remember, I'm kind of leaving out those measurements in my problems. I'll put it on the area model, but there's really no reason to have it in the problem right now. We'll just make sure we write it on our answer, okay? Because sometimes when you write those out and you've got feet in between everything, it starts getting confusing. Okay, so here's my area model. All right, this is reminding us how to get through Zern Lesson 12, basically. So I've got 6.5, and these are feet, aren't they? Okay. And 7 1/3. Now, before we go any further, what in the world is this supposed to mean?
Well, the
One foot are 12 inches.
Okay, so the tiles are 12 square inches. I made you a tile out of rulers here. That's 12 square inches. And I want to know how 12 square inches is any different than square feet. Is it?
No.
No, it's exactly the same. So they put that 12 in there to confuse you and trick you into thinking you've got to add a 12 into your problem somewhere. Okay? That's nothing more than a square foot of tile. Okay? And it's this size right here, these rulers. Okay, so now help me out. Cheney, help me do this first row of the area model. 6 times 7. 42 square feet. 7 times 1/2.
7 halves.
7 halves. I think we'll leave that as a fraction for right now, okay? And then my second row on the area model, Eurydia, help me out. 6 times 1/3.
6/3.
Okay, should I leave that as a fraction, Eurydia?
Yes.
Are you sure? Is it going to end up being a mixed number or a whole number? So if it's going to end up being a whole number, I should change it, right? Just like 2 halves equals 1 whole. So this will be 6 divided by 3. What's that, Eurydia? 2. Okay, and then 1/3 times 1/2. 1/6. Okay, so I'm going to highlight what I need to write down in my problem, but I'm wondering if I can add some of this in my head before I write it down. Okay, so what could I add in my head, Dara, before I write it down?
42.
Plus 2. Okay, so it's going to be 44 plus 7 halves plus 1/6. I don't have much room here, so I'm going to just put my 3 equal signs. And I'm going to do 44 plus. My whole problem is this. Okay? That's what I'm trying to figure out. But I just went ahead and added here. Now I just have to add my 2 fractions. So, in order to add those 2 fractions, I've got to find a common denominator. So get it set up, please. George V. What's your common denominator for 2 and 6?
12.
You could do that. In fact, if you do that, you're going to have to simplify though. So could we choose a smaller one?
6.
Yeah, because 2 divides into 6, doesn't it? Now, I wouldn't count it wrong if you chose 12, but I would probably have to remind you to simplify it. Okay? So 2 times what equals 6?
3.
Okay. And this one's just times what?
1.
Okay, so I have 44 plus 22/6. Next step. Lexi, what do I need to do now?
You need to simplify 22.
Well, I need to change it to a mixed number, don't I?
Yes.
Okay, so the easiest way is to do what? Divide. Just divide. 6 times, Lexi, help me out here. 6 times 4.
6 times 4 is 24, but that's too big. 3. So it'll have to be 18.
Okay, so 6 times 3 equals 18. Then we're going to have to regroup, aren't we?
Yes.
How many of you do this in your head now?
Me.
It's kind of fun, isn't it? 12 minus 8 is, so I have 3 4/6. Okay? What about, let's look at 4/6. Can that be simplified?
Yes.
Yeah, what can I divide by?
2.
Okay, so this is going to be 3 2/3. So 44 plus 3 2/3. What do I get?
4 and 47 and 2/3.
Okay, and that's square feet of tile. So we would need 47 2/3 square feet of tile, which each tile is a square foot, right? We figured that out. And in order to figure out how much it costs, Vaughn, what do you think I need to do here? I gotta take my total amount of tile needed times what? Figure out the cost.
Times 3 2/3.
Well, it's times
Well, I mean 3.
$3.25. Okay, so here's what I want you to do. I've got 47 2/3 times $3.25. Now this is sort of a trick question, and I'm not going to give you any hints right now, okay? That's too hard to do. So we've got to make a decision about how to make that easier to do. So I want you to talk with your table group about this. What are some ideas you have for me? And you can talk with them, okay? What are some ideas you have on how we can multiply this? Because we're not going to use a calculator. So get to talking. Okay, Miguel, what did your group talk about? Stop.
Change it to 3 1/4.
Okay, so you think we should change this to a fraction. 3 1/4 of a dollar, which is 25 hundredths. So that makes sense, okay? And guess what? In block 1, we thought that was the answer too. Just change one of them to a fraction or change one of them to a decimal. If you change this to a decimal, it's 47.66. Okay? But guess what? We don't need to do either one of those. And I want you to try and figure out why.
You have to do it in typical.
Because think about when you go to the tile shop and you're buying tiles. I mean, they literally come in boxes of 10 or so. And when you're buying tiles, think about what you're going to put in your cart when you need 47 2/3 tiles. Don't say it. Talk to your table group about it. What are you going to put in your cart?
Actually, we should do 48 because that is like
Okay, here's something for you. Will they let you take a few tiles out of a box? Yes, they will.
yeah.
They will. Okay? So now go back. What are you going to put in your cart? How many tiles are you going to put in your cart? Abdiel, what did your group discuss? How many tiles do you think you're going to put in your cart? You going to put 47 2/3 of a tile?
No, 47.
Well, then we wouldn't have enough tile to do the bathroom. You're on the right track. Take off the fraction.
Oh yeah, 47 and times.
No? Because you won't have enough tile if you only buy 47. I'm going to pull another stick. George A., how many tiles are you going to put in your cart?
50.
I would buy 50 because you got it. Now, let's go back to him. He says 50 because he's buying it by the box or whatever, right?
The answer.
I would say 50 because I might mess up when I'm using the tile cutter, okay? But 48 is the right answer, okay? How many of you thought it was going to be 48? Very good. Okay, so the multiplication problem, boys and girls, hello, we're still doing this. The multiplication problem you have to solve looks like this. And remember, you're working with money, so when you finish, ignore your decimal until the end, okay? Don't look at mine. Let's see if you can remember how to do 3 by 2 multiplication. I'm going to give you one hint. X's and O's, don't forget. Okay, when you're done, check your multiplication with mine. Don't copy mine, please. you are going into your map test, and you need to remember how to do this, don't you?
Yeah.
Yeah.
There's no tricky questions.
This is a good 5th grade question, it really is. I feel like you're going to get questions like this. They might involve decimals instead of fractions, but you're going to have to do area, and you're going to have to figure out how much it costs, I have a feeling. Okay, so let's take a look at it. If you made a mistake, check to see where you made your mistake so you won't make it in the same place
I
again.
had to
Remember, I'm recording, okay? So just think it.
And also, you don't need the 2 zeros at the end.
Well, you do for money.
Yeah.
For money. I mean, typically, there's 2, it's in the hundreds place. But does that change the value if you don't have those zeros?
No.
No, doesn't change the value. Okay, so how do you feel about that problem? That was a lot. Okay, so your goal today is to finish lesson 12 on Zern. Okay. So during block 1, I tried to draw what Dwayne showed us is getting ready to show us in the video. And I messed it up. So then in block 2 I said, let's just watch Dwayne do it so then I don't have to worry about it. And now I feel like, let's have him watch it again. He always has ideas that aren't in my teacher book of ways to help kids understand math more or math better, okay? So let's just see what he has to say about this lesson. We're moving away from the area model. That's our goal today. All right, so let me...
This is 5th grade Module 5, Lesson 13, and in this lesson, students are going to be continuing to use that area model to understand multiplying fractions. But this time, we're really going to get into the standard algorithm where we take that mixed numbers, change them into improper fractions, but we're going to do it in a way that's not just a rule that students are supposed to blindly follow. We're really going to do it in a logical way that hopefully is going to make sense to our students. So let's get started with this. So parents and teachers, this slide is for you, and it's designed to help you as parents and teachers, the adults who learned the old way, to connect the area model that we have been talking about in previous videos with the standard algorithm that we learned when we were kids, the idea of, well, in order to multiply these mixed numbers, you have to first change them into improper fractions. And of course, we know that you don't have to change them into improper fractions because the previous videos, we've been multiplying just fine using partial products. But let's connect this area model with that standard algorithm that we learned when we were kids. So what I'm going to do first is I'm going to draw in. So we've got 1 1/3 and 3 3/4, all right? But I'm going to draw in what that looks like. And there is our, let's see if I can make this smoother. Okay, so there's our 1, and there is our 3rd. And I did not draw it to scale. It's okay. We don't have to be perfect here. And now I'm going to do the same thing with 3 and 3/4. And so 3 and 3/4. Oh, let's say, let's do 1, 2, 3. And then I want to draw in the 3/4. And, let's do a smaller thing. And let's 3/4. 1, 2, 3. So what do we have? We have 1 here, we have 1 here, we have 1 here, and then we have 1/4 here, and then 1/4 here, and then 1/4 here. Okay. So we can look at this now. What that means is I can get rid of the mixed numbers because we took them and turned them into, we decomposed them, I suppose. into thirds as well, because the denominator over here was 3. And so we could think of this one whole as being chopped up into thirds. So really, instead of having this 1, I'm going to replace that 1, let's see there, and instead of having this 1/3, what do we now have? We now have 4 thirds going on right here.
This is pretty important.
Right here. In the same way, we can do the same thing across the top. We know that everything's been cut into fourths, so I can cut this whole number right here, and this whole number, and this whole number into fourths. So 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. And so now what you can see is what is a whole number. Oh, by the way, we can now get rid of all of these, can't we? I don't know how to do that. Let's see, small gold. There we go. And then, let's see, small gold. That guy go away. That guy go away. And the last thing is that guy go away. Now it's zoomed up. Alright, and so across the top, instead of having 3 3/4, what do we have? Well, we have 4 fourths plus 4 fourths plus 4 fourths. That's 12 fourths. That's 3 times 4 is 12 fourths. And then plus 3 more fourths. So we now have 15 fourths going across the top. Now,
Okay, I'm going to go ahead and stop it there. That's a pretty good visual, isn't it?
Now, the thing I notice about his drawing compared to ours, what's the difference? It was the other way, wasn't it? Okay, so let's go ahead, right here on your paper, let's draw it horizontal. Okay, so all I need you to remember is, what did we have here? Across the top, what did we have? 15 fourths. And here's how we get it numerically, without drawing it. 3 times 4 is 12, plus 3. What's 12 plus 3? And my denominator does not change. Okay? And 1 1/3 becomes what? 4 thirds. Okay? Now, in order to solve this using the standard algorithm, we're done with the area model. We just write the problem. 15 fourths times 4 thirds. Write that out, but then stop. Let's go back to that very first activity we did today, where we were simplifying before we multiplied, okay? And Miguel, tell me if there's anything in this problem I can cross off.
4 and 4.
4 and 4. They become what?
1.
Ones. Okay, anything else, Miguel?
No. Oh, yes.
Well, think about this. Does 3 divide into 15 evenly?
Yeah.
Yeah. So I can actually cross those off also. So 3 divided by 3 is 1. Miguel, what's 15 divided by 3? 5. Okay, so my answer is 5. 5 over 1. What's 5 divided by 1?
5.
So my answer is 5 square inches. That's my answer. Did you like that method? That was pretty simple, wasn't it? On Zern, you're going to see some of this, okay? But then the next one says, determine when the distributive property or multiplication of fractions is more efficient to solve for area. So here's what we have to decide. Is this way easier or more efficient? Or is the area model, which is the same thing as the distributive property, break it apart and add it back together, is this more efficient? Okay? By efficient, they mean takes less time and uses less brain cells, okay? All right, so let's take a look at it. And the only way I can think of to make up my mind about which way is to start out with the standard algorithm. If it looks like it's going to be too hard, I'm switching over to the area model, okay? So standard algorithm is not going to take much room. Draw a line right there. So what I have to do, change 16 and a half to an improper fraction. So 16 times 2
32.
plus one more.
32.
So this will be 33 halves times, Jesus, change 4 1/4 to an improper fraction. So 4 times 4 is 16, plus one more, 17/4. And then I'm going to look at this. Do 4 and 33 share any factors? Too bad that's not 32, right? What about 2 and 17?
Nope.
No, because this is a prime number and it's odd. Okay? So now I'm going to make a decision here. Do I want to multiply 33 times 17, or do I want to see how these fractions add up? I'm going to see how these fractions add up. And it's not going to take us long to make a decision. Okay? So I've got 16 and a half times 4 and 1/4. 4 times 16.
34.
Now, 2 times 16 is 32. So can you do 32 plus 32 in your head?
64.
That was pretty fast.
Oh, easy.
Okay. All right, so I'm going to pull a stick. 4 times 1/2 for me. What is that? 4 halves, which is equal to what whole number? 2. Did you do 4 divided by 2 in your head? Or did you think 2 halves plus 2 halves? Which one of those did you use? Or you just knew it? He just knew it. Okay, the next one. 1/4 times 16, George V. What would that be? 16/4. And that's a whole number also. What whole number is it, George V? 16 divided by 4. 4 times something equals 16. 4. Okay, right away I'm not going to do standard algorithm. I already made up my mind. Why did I make up my mind this way?
You got a whole number.
They're all whole numbers. I've got 3 whole numbers. That means I'm only going to have one fraction to add in. So what's 1/4 times 1/2?
1/8.
1/8. So now in your head, without saying it out loud, this is what you're going to add. 64 plus 2 plus 4 plus 1/8. Beverly, what'd you get?
That's 70 and
70 and 1/8. You guys agree?
Yes.
So that was pretty simple because my fractions worked out to be whole numbers. That's not always going to happen. If I could have crossed off, then I probably would have finished this method out. Okay? But it makes no sense when I started my area model and I saw that was a whole number, this was a whole number. My decision was made for me. Okay? All right, let's keep going. So problem 3 is pretty difficult. In fact, Jocelyn, my senior aide, said she had a problem like this on her test to see if she could take college algebra. So, are you paying attention? Okay. An 8-inch by 10-inch picture is resting on a mat. 3/4 inch of the mat shows around the entire edge of the picture. Find the area of the mat not covered by the picture. So what I'm going to do right now is I'm just going to highlight what we need to figure out. This is the area of the mat not covered by the picture. Okay? So whatever I've highlighted in green is what we're going to have to figure out the area of. And that's going to be kind of hard. I can't just do 3/4 times 3/4, can I? Or can I?
You can, but then you're gonna have to.
I'd have to do it several times, wouldn't I? Because I'd have to figure out how long this is and how wide it is. So I have an idea. Would you like to hear my idea? First of all, what's the area of the picture? 80. So I'm going to put area equals 80 inches squared. Can't see that very well, can you? Okay. So I have an idea. What if I were to extend this out to the edges? That way I could use my 8 inches right here. What do you think? Pretty good idea. So then that means how big is this? No, it tells you right here. 3/4. And so how big would this part be? 3/4. So I've got 8 plus 3/4 plus 3/4. We'll get back to that in a minute. Okay? So then, what if I would extend this out here so I could use the 10 inches? What do you think? Okay. So how much would this part be? 3/4. And how much would this part be right here? Same as that. 3/4. Do you see where I'm coming from? It's 3/4 all the way around, so it has to be 3/4 and 3/4. Okay, so now I know my total dimensions of the total board. So I could do the total, whatever's in the frame, I guess, and then take out the picture to figure out the green part. What do you think?
Yeah.
Okay, so tell me, could I add any of this ahead of time? Yeah. There's a couple ways to add it. I could do 3/4 plus 3/4. What's that? 6/4. Write it down. Change that to a mixed number.
1 and 2 plus.
Oh, somebody else said 1 and 1/2. Who said that? Okay, good. So we've got 10 plus 1 1/2. 10 plus 1 1/2 is, so this is 1 1/2. Abdiel, what's 10 plus 1? Add a half. Okay, that's my width. Now my length is 8 plus what? 1 1/2. What's 8 plus 1?
9.
Plus a half.
9.
So there's what we have to figure out. That would be the total, whatever's in the frame, the total area. Then we can take out the picture to figure out how much mat there is. Okay? So what are you thinking here? Standard algorithm, or remember how we made our decision? How did we make our decision? We wrote down the standard algorithm to check to see if we could cross anything off. Okay? So 9 times 2.
18.
Plus what?
19.
So I've got 19 halves. Write this down. What's 11 times 2?
22.
Plus 1. Okay, so 19 and 2, do they share any factors?
Nope.
What about 2 and 23?
Nope.
Bummer. But I know something. I know a half plus a half is a whole. And I feel like that might help us here when we do our area model. So go ahead and write your area model. Label it. Now remember, this is going to help you on lesson 12 Zerd. So 11 times 9, boys and girls.
20.
99.
Oh.
11 copies of 1/2. Let's change that to a mixed number. Let me pull a stick there. 11 halves. Abdiel, what is that as a mixed number? Now, if it helps, Abdiel, you could do this. 11 divided by 2. Okay? Five and a half. Good. Okay, so a half times 9 is 9 halves, correct? Okay. Dara, change 9 halves to a mixed number. So you could do 9 divided by 2. Four and a. Okay, so what am I going to add up? Oh, I need one more. What is a half times a half? 1/4. Okay, so here's what I'm going to add up. 99 plus. Now, there's something I could do. I could do 99 plus 11 halves plus 9 halves. That would be 20 halves. Okay? Or I could do 11 plus 5.5 plus 4.5. Whoops. So let's go with 5.5 plus 4.5, but you could leave it as a fraction, plus 1/4. Okay, so 99, well, let's do 5 plus 4, 9, right? What's a half plus a half?
109.
So 99 plus 10 plus 1/4. What do we get? 109 and 1/4 inches squared. Okay, you ready? Draw a little tape diagram here. That's my total. 109 and 1/4 inches, right? Okay. What's the total of my picture? 80. So my question mark is, how much is left over after that? Okay. Now you can go ahead and do 109 minus 80. And then put your 1/4 on. What's your answer? 29 and 1/4 square inches is the area of the mat not covered by the picture. That was a pretty good problem. You might run into something like that. Okay, hold on.